Hi everyone, today we are going to discuss about Zilliqa, a next-gen, high-throughput and highly scalable blockchain platform. But first, let me tell you about who are we. We are Blockchain at India, a community formed by blockchain enthusiasts trying to help undergrads across the country by providing them with necessary resources. We aim to start college chapters at different universities across India and empower students in emerging technologies. This way, we can help the youth of our nation build a decentralized future. Who Let me tell you about me. I am a core member of Blockchain at India and a blockchain engineer at Daz Labs. Now let's start about Zilliqa and how it's different from other blockchains. In a traditional blockchain consensus, every participating node on the network has to validate each transaction sequentially. On these blockchains, as the number of transactions increase, the need for additional nodes to process and store transactions also increases, and this leads to scalability issues. In these systems, data also has to travel a lot more before being validated and stored by all the nodes. Now let's see how Zilliqa solved these problems. Zilliqa has three main features: network sharding, easier implementation of smart contracts, and a hybrid consensus protocol which includes POW and PBFT. Here, POW stands for proof of work and PBFT stands for practical Byzantine fault tolerance. Now, what is network sharding? Network sharding is simply breaking of nodes into groups called as shards. Zilliqa uses Scylla rather than Solidity, which makes it easier to implement smart contracts. And Zilliqa also uses a multi-layer consensus protocol, which is POW and PBFT. Now, we will discuss all of these three features in detail. Now, let's talk about network sharding. What does network sharding bring to the table? Network sharding is simply division of nodes into different groups called as shards. Network sharding uses a divide and conquer algorithm in parallel. In network sharding, let's take an example. Let's say we have 1000 network nodes and we divide them into into a size of 10 network nodes. So we have 100 shards. This here what happens is that 100 transactions will take place together rather than a single transaction on a network. This is what network sharding is. It brings faster transactions to the table. Now let's talk about there are three major problems which sharding face. The three major problems are Sybil resistance, shard creation, and shard size. Let's take an example for Sybil resistance where one node tries to span using multiple identities and influence majority decisions. This is an example of 51% attack for when majority of nodes try using more than one identity, then 51% attack can easily take place. Then there is shard creation. The problem of shard creation, that who will create the shard. Let's take an example that a particular team is creating shards. Then what happens if that team turns malicious? That may compromise the security of the whole network. Then the problem of shard size is that what will be the size of the shard. For example, if we take 1000 nodes and we create 100 shards of 10 nodes each, then this won't be feasible as there can be majority of malicious nodes in a shard, and that will simply compromise the security of the system. Now let's see what is Zilliqa's approach towards these problems. Zilliqa uses POW for Sybil resistance. So a person will need to solve a complex problem involving very high computation problems. POW serves as an entry ticket to the network, thereby making it hard for any real-world entity to span multiple identities. Then there is automatic shard creation by the DS committee. The DS committee creates the shards and elections for DS committee are regularly held. A member of the DS committee is pushed out using a first in first out approach, and the one who solves the problem the fastest is the new node elected in DS committee. Then all the nodes in the network now perform another POW validated by the DS committee. Depending on POW and some randomness, a shard is assigned to a node. Then then there is approach of keeping the shard size to 600. Zilliqa considers a minimum shard size of 600, where we take the probability that at least 1 by 3 of the network nodes are malicious. Since we need a supermajority of voters, so shard size of 100 is insecure. Now we move on to the consensus of Zilliqa, which is a hybrid one. As we discussed, it includes POW and PBFT. In the key benefits of PBFT are transaction finality and a higher efficiency, since POW is used only as an entry ticket. Now let's move on to the smart contracts in Zilliqa. Zilliqa uses a language called as Scala, which is used for smart contracts. Scala simply uses a data flow approach and non-Turing complete contracts, which are easier to implement as compared to Solidity. That's all about Zilliqa blockchain. I hope that you now have a basic understanding of Zilliqa. Stay tuned for more such videos. If you want to start a Blockchain at India college chapter at your university, feel free to drop us an email. Do not forget to follow us. Thank you. Have a nice day.